What if I told you that American muscle wasn't born in Detroit's 1960s factory floors, but in the muddy trenches and desperate skies above World War I? Picture this. It's 1917, and America has just entered the Great War with exactly 0 combat-ready aircraft engines. 0. The Europeans had been perfecting their power plants for 3 years of brutal aerial combat, while American pilots were still flying French machines. In just 5 days, 2 rival automotive engineers would design an engine that not only saved American aviation, but accidentally invented the blueprint for every performance V engine that followed. May 29, 1917, the Willard Hotel, Washington, D.C. 2 men who should have been competitors sat across from each other in a locked room. Jesse Vincent from Packard and Elbert Hall from Hall Scott Motors. Their mission from the U.S. Aircraft Production Board was impossible. Design a standardized aircraft engine that could be mass-produced by American automotive factories, powerful enough to match European designs that had years of combat refinement, and do it fast enough to get American pilots in the air before the war ended. They had no computers, no CAD software, not even a proper drafting table, just paper, pencils, and the combined knowledge of America's 2 best engine designers. This is the story of the Liberty L-12, the 27-liter V-12, that transformed America from an automotive backwater into the arsenal of democracy, and more importantly, proved that American engineers could build power on a scale the world had never seen. To understand what Vincent and Hall accomplished, you need to understand what they were up against. By 1917, the air war over Europe had become a brutal Darwinian laboratory for engine development. The British had their Rolls-Royce Eagle pushing 360 horsepower from 20 liters. The French had the Hispano-Suiza 8 with its revolutionary geared cam drive producing 200 horsepower from just 11.7 liters. The Germans were fielding the Mercedes D3 and the mighty BMW 3A with its high-altitude compensation system. These weren't just engines. They were the product of thousands of hours of combat testing, countless dead pilots teaching engineers what worked and what got you killed. America had nothing even close. The best domestic design was the Curtiss Ox-5, producing a pathetic 90 horsepower. American pilots training in France were begging to fly anything but American equipment. The Army Signal Corps' aviation section had ordered 366 aircraft engines from domestic manufacturers in 1916. By early 1917, they had received exactly 64, and most of those were defective. The Wright-Martin Company had spent 2 years trying to copy the French Hispano-Suiza and managed to deliver exactly 0 working engines. The Thomas Morris Company claimed they could produce 100 horsepower from their rotary design. During testing, it barely managed 75 before destroying itself. But here's where it gets interesting. Vincent and Hall didn't try to copy European designs. Instead, they looked at what America did better than anyone else: mass production. The Liberty wasn't designed to be the most sophisticated engine or the most powerful per liter. It was designed to be built by Buick assembly line workers who had never seen an aircraft engine before. The design they sketched out in that hotel room was revolutionary in its simplicity. A 45-degree V-12 with individual steel cylinders that could be manufactured on existing automotive machinery. Each cylinder displaced 2.24 liters with a bore of 5 inches and stroke of 7 inches. The compression ratio was just 5.4.1, deliberately conservative to run on the 70-octane fuel available in France. No exotic materials, no complex valve gear, just massive displacement and American mass production techniques. But the real genius was modularity. The Liberty wasn't one engine design, it was a system. The same cylinders, pistons, and valve gear could be assembled as a V8, V12, or even an experimental V6. If a factory could only handle V8 production, they built V8s. If you needed more power, bolt on 4 more cylinders. Every part was interchangeable across all variants. A mechanic in France could cannibalize 3 damaged engines to build 1 working unit without any specialized tools. Within 28 days of that hotel room meeting, the first prototype was running on a test stand. Think about that. From blank paper to firing engine in 4 weeks. The automotive industry had never moved that fast before. The prototype immediately produced 301 horsepower at 1,600 RPM. Not spectacular by European standards, but remember, this was designed for mass production, not maximum specific output. By August, the improved design was pushing 410 horsepower. The cylinders now featured welded-on cooling jackets instead of cast units, saving weight and improving heat dissipation. The crankshaft was a masterpiece of American metallurgy, forged from chrome-nickel steel and balanced to tolerances that wouldn't be standard in automotive production for another 30 years. The connecting rods were machined from chrome vanadium steel forgings with an I-beam cross-section that provided maximum strength at minimum weight. The valve gear deserves special attention. Each cylinder had 2 overhead valves operated by a single overhead camshaft per bank. The cam lobes actuated rocker arms that opened the valves through a simple but robust mechanism. No complex desmodromic systems like some European designs, no fragile gear trains. Just American brute force engineering that could be maintained by a farm mechanic from Iowa who had been drafted 6 months earlier. Here's what made the Liberty truly revolutionary: the production system. Within 6 months, Packard, Lincoln, Ford, General Motors, Nordyke, and Marmon were all building Liberty engines. Not similar engines, not licensed variants, the exact same engine with completely interchangeable parts. A cylinder manufactured by Ford in Detroit would fit perfectly on a crankcase made by Packard in Indianapolis, using a camshaft ground by General Motors in Flint. The production numbers were staggering. By November 1918, American factories were producing 150 Liberty engines per day. The British needed 6 months to build 100 Rolls-Royce Eagles. American factories built that many Liberties every 16 hours. Total wartime production reached 20,178 engines in just 18 months. Half of all Allied aircraft engines produced in 1918 were American Liberties. But production volume was only part of the story. The Liberty transformed American manufacturing culture. Packard developed new aluminum casting techniques that would later appear in every high-performance engine they built. Lincoln created precision measurement systems that became the foundation of their luxury car reputation in the 1920s. Ford learned mass production techniques for complex assemblies that would revolutionize their automotive operations. The Liberty's combat record speaks for itself. The DH-4 bomber equipped with the Liberty became the backbone of American air power. During the Meuse-Argonne offensive, Liberty-powered aircraft flew 150 combat missions per day, dropping 75,000 pounds of bombs on German positions. The Liberty-powered MB-3 fighter could reach 140 miles per hour and climb to 10,000 feet in 9 minutes. Not spectacular compared to a Sopwith Camel with a Bentley BR2, but remember, America was building 20 of these for every rotary engine the British produced. The engine had its problems. Early versions suffered from connecting rod failures at high RPM. The solution? Thicker rod bolts and a rev limiter that prevented pilots from exceeding 1,800 RPM. The cooling system was marginal in climb conditions. The fix? Larger radiators and operational restrictions on sustained climb angles. These weren't elegant solutions, but they worked, and more importantly, they could be implemented without redesigning the entire engine. Let me put the Liberty's impact in perspective. The Mercedes D3A that powered the fearsome Fokker D7 produced 180 horsepower from 14.7 liters. That's 12.2 horsepower per liter. The Liberty VI-12 made 410 horsepower from 27 liters, only 15.2 horsepower per liter. But while Germany struggled to build 50 Mercedes engines per month, America was building that many Liberties before lunch. Every single day, the engineering philosophy behind the Liberty would define American performance engines for the next century. Don't chase specific output, dominate with displacement, don't complicate, build it strong and build it by the thousands. Don't perfect, iterate rapidly, and fix problems in production. This wasn't sophisticated European engineering, this was American industrial warfare. After the war, surplus Liberty engines transformed American aviation and motorsports. Bootleggers bolted them into speedboats that could outrun any Coast Guard vessel. Racing drivers stuffed them into purpose-built land speed record cars. In 1923, a Liberty-powered Streamliner hit 133.75 miles per hour at Daytona, a speed that wouldn't be exceeded by a production car for another 25 years. The Liberty taught American engineers that big displacement V engines could be mass-produced reliably. Cadillac's 1930 V16 can trace its design philosophy directly to Liberty engineering. The aluminum block construction pioneered for Liberty production showed up in Chevrolet's revolutionary 1955 small block V8. The modular design concept appeared again in Ford's 385 series big blocks of the 1960s. But here's the part most people don't realize. The Liberty didn't just influence automotive engines, it created the American performance culture. Before 1917, American automobiles were about reliability and affordability. The Model T conquered the world not with speed, but with simplicity. The Liberty proved Americans could build power, massive, brutal, accessible power, better than anyone else. The technical innovations were staggering for 1917. The Liberty used a forced lubrication system with a gear-driven oil pump, maintaining 50 psi of pressure to all bearings. European engines of the era still relied on splash lubrication for many components. The ignition system featured dual magnetos with automatic advance, providing redundancy that would become standard in aircraft engines for the next 50 years. The carburetor was a Zenith dual-throat design that could be adjusted for altitude compensation, though most pilots never bothered learning how. Consider the metallurgy. The Liberty's aluminum pistons were cast using a process Packard developed specifically for this engine, achieving a strength-to-weight ratio that wouldn't be matched in production automobiles until the 1950s. The valve springs were wound from chrome vanadium steel using progressive pitch rates, tighter coils at the bottom, looser at the top, to prevent harmonic resonance at high RPM. This technology wouldn't appear in production car engines until the 1960s muscle car era. The cooling system alone was revolutionary. Unlike European engines that relied on complex water pump arrangements, the Liberty used thermosiphon cooling augmented by a simple centrifugal pump. Hot water rose naturally through the cylinders to the radiator, while the pump ensured flow during ground operations when airflow was minimal. The radiator itself used a honeycomb core design with 36 cooling fins per inch, a density that wouldn't be achieved in automotive applications until modern aluminum radiators. The Liberty transformed America's industrial base. Before 1917, precision manufacturing was limited to small shops producing hundreds of units. The Liberty required millions of precisely machined parts, interchangeable across multiple manufacturers. General Motors developed new quality control systems, measuring parts to tolerances of 0.001 inches. Ford created specialized heat treatment facilities that could process thousands of crankshafts per day. Packard invented new assembly line techniques that reduced engine assembly time from 300 hours to just 75. The human cost of this achievement was significant. 7 test pilots died during Liberty development. 38 workers were killed in factory accidents, as companies rushed to meet production quotas. The Packard factory in Detroit ran 3 shifts, 7 days a week, for 18 straight months. Workers who had been building luxury car engines suddenly found themselves part of the war machine, their craftsmanship replaced by production quotas. But the Liberty also created heroes. Jesse Vincent became the godfather of American aviation engines, later developing the Packard engines that would power the P-51 Mustang to victory in World War II. Elbert Hall's modular design philosophy influenced a generation of engineers. Charles Kirkham, who refined the Liberty's valve gear, went on to design the engine that powered Charles Lindbergh's first aircraft. The international impact was immediate. The British licensed Liberty production, but could never match American output. The Italians bought 3,000 engines and used them to establish altitude records that stood for a decade. The Japanese studied captured Liberty engines extensively, their findings influencing Mitsubishi and Nakajima designs throughout the 1920s and 30s. Racing history was rewritten by surplus Liberties. The 1920 Indianapolis 500 featured 8 Liberty-powered cars. The winner, Gaston Chevrolet in a Monroe, averaged 88.62 miles per hour using a modified Liberty Straight 8, producing over 300 horsepower. Land speed record attempts throughout the 1920s relied on multiple Liberty engines. The Triplex Special used 3 Liberty V12s, producing a combined 1,200 horsepower, though it killed driver Lee Bible when it crashed at over 200 miles per hour in 1929. Marine applications pushed Liberty engineering even further. Garwood's racing boats used supercharged Liberties producing over 600 horsepower. The cooling systems were modified to use raw water injection, the compression ratios raised to 7.1 for racing fuel, and the RPM limits removed. These monsters could push a 38-foot hull to over 70 miles per hour, speeds that terrified even experienced racers. The Liberty's influence on American automotive culture cannot be overstated. Before 1917, American cars were utilitarian. After thousands of veterans returned home having maintained and modified Liberty engines, they wanted power in their personal vehicles. The hot rod culture of Southern California in the 1930s can trace its roots directly to surplus Liberty parts, finding their way into modified Ford Model A's. The flathead V8 that became the foundation of 1950s hot rodding borrowed heavily from Liberty design principles: simplicity, displacement, and mass production. Technical evolution continued through the 1920s. The Army Air Service developed the Liberty 12A, featuring improved cylinder heads that raised output to 440 horsepower. The Navy created the Liberty 12N with reinforced internals for marine use. Packard privately developed a racing variant producing 500 horsepower at 2,000 RPM, though only 3 were built. Each iteration taught American engineers more about extracting power from large displacement V engines. The modularity concept pioneered by the Liberty appeared everywhere in American engineering. General Motors' small block V8 family used the same principle: one basic architecture scalable from 265 to 400 cubic inches. Ford's FE series big blocks followed the Liberty template of modular displacement using common components. Even modern LS engines trace their interchangeability philosophy back to that hotel room in 1917. Material science advanced decades because of Liberty production needs. Aluminum alloy development accelerated to meet cylinder head requirements. Steel metallurgy improved to handle the stress of mass-produced connecting rods. Bearing technology advanced from simple Babbitt to copper-lead alloys that wouldn't see automotive use until the 1940s. The Liberty forced American industry to solve manufacturing problems that peacetime would never have presented. Quality control systems developed for Liberty production became industry standard. Statistical process control, random sampling, and tolerance stack-up analysis all emerged from the need to ensure parts from different manufacturers would work together. Packard's quality manual for Liberty production became the template for military specifications that governed defense contracting through World War II and beyond. The Liberty's 27 liters of displacement seems almost quaint compared to modern aircraft engines, but consider the power density evolution it started. The Liberty made 15 horsepower per liter in 1918. The Packard Fied 1650 Merlin that powered the P-51 Mustang made 60 horsepower per liter in 1943. Modern naturally aspirated automotive V12s achieve over 100 horsepower per liter, but they all follow the basic architecture Vincent and Hall sketched out. V configuration, overhead valves, aluminum construction, precision, mass production. Cultural impact extended beyond engineering. The Liberty proved America could compete with European sophistication through industrial might. This philosophy would define American manufacturing through the 20th century. Don't build the best, build the most. Don't perfect, iterate, don't customize, standardize. These principles would help America become the arsenal of democracy in World War II and the world's industrial superpower afterward. The Liberty engine program cost approximately $450 million in 1918 currency, roughly $8 billion in today's money. Critics argued the money would have been better spent licensing proven European designs. They missed the point. The Liberty wasn't just about building engines. It was about building the capability to build engines, the factories, techniques, and expertise developed for Liberty production would produce 100,000 aircraft engines in World War II, including 55,000 Packard Merlins that powered British and American fighters to air supremacy. Post-war surplus created unexpected innovations. Liberty engines powered the first successful helicopters, their reliability and power-to-weight ratio ideal for vertical flight experiments. They ran pipeline pumps in Texas oil fields, their aircraft heritage meaning they could run continuously for thousands of hours. Modified Liberties powered electrical generators in remote locations, bringing power to rural America throughout the 1920s. The racing legacy continued for decades. Liberty-powered unlimited hydroplanes dominated water speed competitions through the 1950s. The thunderous roar of unmuffled Liberty 512s became the soundtrack of American motorsport between the wars. Even today, vintage aircraft enthusiasts pay over $100,000 for a rebuilt Liberty, its massive displacement and mechanical simplicity making it ideal for warbird restorations. So what was the Liberty L-12 really? It wasn't the most advanced aircraft engine of World War I. It wasn't the most powerful or the most efficient, but it was the most important. In 5 days, 2 engineers created not just an engine, but a philosophy. Big displacement, mass production, interchangeable parts, rapid iteration, brute force over finesse. This wasn't just an engine design, it was the birth of American muscle. The Liberty proved that American industry could mobilize faster, produce more, and iterate quicker than any nation on Earth. It showed that American engineers could take European sophistication and make it buildable by the thousands. It demonstrated that in modern warfare, the ability to produce good enough by the thousands beats perfect by the dozens. Every American V8 that followed owes something to the Liberty. Every mass-produced performance engine carries its DNA, the idea that power should be accessible, that performance should be democratic, that displacement beats sophistication. These all started in that hotel room in 1917. When a teenager in 1965 bolted a 427 big block into his Chevelle, he was following a tradition that started with Jesse Vincent and Elbert Hall. When Ford decided to stuff 7 liters into the GT 500, they were chasing the same philosophy the Liberty pioneered. There's no replacement for displacement. The Liberty V12 wasn't just the first mass-produced American aircraft engine. It was the moment American engineering found its voice. Not through European refinement or sophisticated technology, but through accessible power produced at a scale the world had never imagined. It was the first time American engineers said, "We're not going to build it better, we're going to build it bigger, stronger, and by the tens of thousands." That's the real legacy of the Liberty, not the 20,000 engines or the combat record or even the racing victories. It's the philosophy that American performance should be democratic, that power should be accessible, that engineering excellence means building something that works reliably at massive scale. Every time a Hellcat engine fires up its 6.2 liters of supercharged fury, it's echoing the Liberty's roar from a century ago. The Liberty didn't just power aircraft through World War I, it powered the American century that followed. And that thunder that started in a Washington hotel room in 1917, it's still reverberating through every American performance engine built today. What's the most impressive example of American engineering overkill you've encountered? Let me know in the comments below. And if you enjoyed this deep dive into the engine that started American muscle, make sure to subscribe for more stories of legendary power plants that changed the world. Until next time, keep those engines running.